Hello everyone, welcome to my channel. So in this video, we will continue our topics on the confidence interval, or say the statistic intervals for our statistics. So in the previous video, we already talked about why we want to do statistic intervals and how in general we can try to find the statistic intervals, like we want to the true value of our population parameters is inside this or lying inside these intervals to give us a specific probability of 1 minus alpha. So in that one, because this is also related to the probability, right? So that means we want to have some specific assumptions of the distributions for this probability. So here for this videos, we will focus on the normal distributions, and here we have a specific requirement. That means the variance is known. So that means here for these populations, what we have is we have select a random sample from our population, and this population follows a specific distribution. So this is a normal distribution with the population mean as denoted by mu, and the population variance denoted by sigma square. So here the specific requirement for here is we want to say we don't know the parameter mu of our population, so this is unknown. But actually the sigma square, the variance, we know this. So that means here, because we don't know the true value of our population mean, what we want to do first is we will use the point estimations to give an estimator of this value. And then if we use the sample mean x bar to estimation our population mean, then here for this confidence interval, what we want to find, we want to find this interval with a left endpoint as L and right endpoint as R to make the true value of our population mean is inside or between these two values. So here, of course, here we have one more numbers. This is 1 minus R. We want in the 1 minus alpha probabilities, this true value mu is between these two left and right endpoint. Okay, so now for this one, in the end of the last videos, I already said in my videos of the normal distribution random variable in the playlist probability, I already explained how we can use the standard normal table to help us find an interval, symmetric interval, satisfies our random variable is between this inside this interval with a specific probability. So if you haven't looked at that videos, then I strongly recommended you to look at that one. And here inside this part, one thing I need to do is, because we only have the standard normal random variable table, right? So the first thing, if we want to do this, the first step is we need to know what is the distribution of our value mu, and then we need to know how to rewrite this to a standard normal random variable. So that means we need to use the standardization of the normal distribution. Okay, so here for our population mean, what we have. So here, because we don't know the true value of our population mean, so what we will do is actually we use the sample mean x bar to estimate this one, right? So the previous equation actually is becomes L is smaller than x bar is smaller than R. So by this one, when we normalize our standard normalize our normal distribution, what we do is we define a z is equal x bar minus mu divided by the new variance. So here this is. So if you're confusing about why for this sample mean, they follows normal distribution with mean as mu and variance as sigma square over n. So you should look at our previous videos about the linear functions and also about the about this part. So I will give a link here. So based on this new definition of our capital Z, the previous equation actually is become the following equation. So now this actually is our process for the standardize our normal distribution, and because we rewrite this middle term as capital Z, so now our equation is looks like the L on the left is a standardized of our left endpoint smaller than our new variable Z, and the standardize of the right endpoint. So now what we want to do is we want to find this left endpoint and right endpoint. So here I denote this by new 1 and 2. We want to denote this 1, 2 term. Satisfy this probability of Z is between this left and 1 and 2 terms is equal 1 minus alpha. Okay, so now what we should do is we should use the asymmetric property of our standard normal distribution. So here, because our standard normal random variable is have a symmetric PDF. So here this is about the PDF of our standard normal distribution. So I denote this by small fx. And then by this one, because it's symmetric and symmetric with respect to our small z is equal 0. So now if we try to find a left endpoint and right endpoint of this one to make the probability is equal 1 minus alpha. So here this is means if we say this is our 1 and this is our 2 by the symmetric, that means the sum up of this shadowed by red color, the sum of this one should equal alpha. And also because this one is symmetric, so that means for each of them the probability is equal alpha over 2, right? So only half of this probability alpha. So now what we have is actually we try to find a value of left and right endpoint. So here this 1 and 2 term, in general we denote this by a special symbol as negative z alpha over 2 and positive z alpha over 2. So because the symmetric of this graph, so that means here we know this 1 and 2 actually is 2 is positive value and 1 is negative value, but they will have the same value of the absolutely value. Okay, so now the question is become we try to find the value of z alpha over 2 such that looks like this. And to find the value of this z alpha over 2, so actually this is two ways. One way is we first find the value of z alpha over 2. And then we know the negative, the left endpoint, negative z alpha over 2 is just, add a minus before this. Or we try to find the value of the left endpoint and then to find, to imply the right endpoint. So here, this is two ways. The first is we try to find this one. So we have these two equations to find the value. So the first will give us the value of the left endpoint and the second will give us the value of the right endpoint. Okay, so to get these two values, actually we just use our table of the standard normal random variable. So we know what is the probability. So that means we know which point we want inside this table, and we try to find the column name and the row name of this for intersection this probability value. Okay, so now if we find this of our left endpoint and right endpoint. So don't forget this left endpoint and right endpoint is our equation. One is for left endpoint. Right now we call this is negative z alpha over 2, and then the right is positive z alpha over 2, right? So now we know this two value, but what we want is this capital L and capital R. So then what we have is we just have this equation as left endpoint is equal the x bar minus z alpha over 2 times the value of our new standard deviation. And then the right endpoint is two term is same, it's just here we have this is a plus the second term. Okay, now we already explained all the process, how we can use the standard normal random variable table to help us find the left endpoint and right endpoint. So now let me summarize what we talk about here. So here for this one, if we want to find a confidence interval for this given alpha, so that means we try to find the 101 minus alpha percentage confidence interval for our population mean. When we know the population variance sigma square, so we know the left endpoint and right endpoint is right here. So here we know that this actually is a symmetric interval with respect to our sample mean x bar. So here we just call this term z alpha over 2 times sigma over square root of n as the margin of our error. So that means here this is a way to describe how far from our estimator to our true value. Okay, so this is about the materials for this confidence interval for this normal distribution when variance is known. However, for this one, actually, we have this is a symmetric intervals with respect to our x bar. So if you want to have a one-side confidence intervals, so this is about the one-side confidence bounds for our population mean. So we have also have the 101 minus alpha percentage, the upper and the lower confidence bounds for our population mean when the population variance is known. So here this is about just actually a one-side intervals. So you can think this is from negative infinity to this term, and the lower one is from the a given term to the positive infinity. Okay, so here there is a one thing you need to careful is for the one side confidence bounds for our margin of error, this will become z alpha, not z1 alpha over 2. So the reason is now we only focus on one side of this estimation or intervals. So that's why we don't need to divide it by 2 for a two-sides bound. Okay, so this is my explanation of this materials for how to find confidence interval and also how to find the confidence bounds when our variance is known. So in next video, I will start to talk about what will happen if we don't know the variance of these populations. So please subscribe this channel and see you in next video.